Welcome to our mathematics lesson. And in our maths lesson today, we are going to look at fractions, decimals, percentages, and financial mathematics. And for us to start on this, we shall first start by reviewing what we initially know and then proceed to what we find that is required from this prerequisite knowledge. Now, I want us to remind ourselves about equivalent fractions. We said that if fractions are said to be equivalent when simplified, they form the same fraction. For example, 1/2 and 4/8 can be said to be equivalent fraction because when you simplify 4/8 further, you'll get by 4 is 1, by 4 is 2, you'll get 1/2. Therefore, 1/2 is equivalent to 8/4. Now, for us to start on, let us remind ourselves a few things about the fraction. In a fraction, we have this, which we call the numerator. We also have these two, which we call denominator. This is a fraction. Now, when you have a fraction in a different manner where we have the numerator being greater than the denominator, like this case 4/3, then this one is called improper fraction. We also have a mixed fraction, and a mixed fraction is a combination of a whole number and a fraction part. For example, 2 and 1/3 is taken to be a mixed numeral. So this is a mixed numeral because it has got a whole number part and a fraction part. Now, we shall be required to apply the knowledge of various terminologies that we use in fractions, and I want you, during your free time, to look at the following terminologies and refer to your previous exercises and notes that you've learned and be able to come up with what the following terminologies means. We have numerator, denominator, improper fraction, proper fraction, mixed numeral, highest common factor, lowest common denominator. We have factors, we have multiples, and many others. So at your own free time, look at those words and get to know what they simply mean. So let us start by looking at the equivalent fractions. So when we talk about equivalent fractions, these are equal in value. Equivalent fractions are simply equal in value. They are equal in value. They can also be shown on a number line. Let us consider the following. Let us consider 3/5 and 6/10. These two fractions are said to be equivalent, and it can be shown on a number line. The position of 6/10 is somewhere here, and the position of 3/5 is here. So you notice that 3/5 and 6/10 simply means an equivalent of the other. It is the same, or it is a fraction that carries the same weight. This one can also be seen when you simplify this. We find this is 3/5. When you choose to simplify 6/3, you will get 2, and 6/2, you get 3, and by 10/2, you get 5. So it is equivalent 3/5. That is an equivalent fraction. It can be shown on what we call a number line. Equivalent fractions are also formed by multiplying or dividing by a number that is equal to 1. It is formed by multiplying or dividing by a number that is equal to 1. Now, let us take a fraction like 2/5. When we talk about a number that is equal to 1, there are so many numbers. 2/2, 3/3, 4/4, 7/7. All these numbers are all equal to 1. So when we say multiplying by a number that is equal to 1, it is the same as saying multiply here by 2/2. This one will give us 4/10. So 2/5 is equivalent to 4/10. It has been obtained by multiplying by a number which is the same as 1. Equivalent fractions can also be obtained by simply multiplying the numerator and the denominator by the same whole number. When you talk about a whole number, is a number that is not a fraction, like 5, 10, 2, 3. Those are all numbers. So take 2/7. Now, when you take this, if you choose to multiply the numerator, which is this one, 2/3 and 7/3, multiply the numerator by the same number as the one multiplied by the denominator, you find this one will give us 6/21. 6/21 is the same as, or is equivalent to 2/7. So this 2 are equivalent. They are equivalent fractions. We can also obtain an equivalent fraction by dividing by as the same number, dividing the numerator and the denominator by the same number. Let us take 10 over 24. This is a fraction. If we divide here by 2 and divide this one by 2, then we shall get 10 by 2 is 5, 24 by 2 is 12. So we are saying 5 over 12 is equivalent to 10 over 24. So these two are equivalent fractions. Now, also when we talk about fraction, we can also obtain equivalent fractions by simply identifying what I'll call the factors, and then from the factors you cancel what is common from the denominator and the denominator. For example, (12/18), you realize 12 is the same as I'm writing it in form of factors, product of factors, that is 2 multiplied by 2 multiplied by 3. 2 times 2 is 4 times 3 is 12. And 18 is equivalent to 2 multiplied by 3 multiplied by 3. This is a product of what we call prime numbers or factors. So what is common on top and what is common at the bottom? Or what forms the numerator and what forms the denominator? We look for common factors. For example, 2 is up, 2 is down, and they only cancel once. So I'll cancel 2 and 2. 2 is here, but 2 is not there, so we don't cancel that. 3 is here, 3 is here, we cancel that. We shall remain with 2 over 3. Therefore, 2 over 3, they are also the two fraction 2 over 3 and 12 over 8 also forms another pair of equivalent fraction. This can also be obtained when we divide by highest common factor. And highest common factor is the number that, the highest common factor is that factor which is the highest, and it's common to divide both the numerator and the denominator. So that is what we mean when we say divide by highest common factor. And the highest common factor for 8 and for 12 and 18, you realize it is what? 6. So by 6 here is 3, by 6 here is, by 6 up there is 2, by 6 down here is 3. So we have 2 over 3 as, we have 2 over 3 as, we have 2 over 3 as our equivalent fraction having been simplified. We write the following fractions with a denominator of 40. 3 over 5, 1 over 2, and 7 over 4. Now, we have 3 over 5, and we want it to give us an equivalent fraction of x over 40. For us to be able to get the unknown numerator, because the denominator we've been told it must remain 40, we shall take the new denominator divided by the first denominator, which is 40 divided by 5. And 40 divided by 5, you'll find it's 8. Therefore, this part you'll simply multiply by 8 to get what x is. And this one will give us 24 over 40. So 3 over 5 is equivalent to 24 over 40. So the two are equivalent. The denominator is 40. Similarly, when you look at a half, what happened to a half to 2 to give us 40? What happened to 2 to give us 40? 40 divided by 2 is 20. Is 20. Therefore, 2 times 20 is 40. We should do the same to the numerator, so we shall multiply by 20, and you get this is 20. So a half is the same as 20 over 40. So a half and 20 over 40 are equivalent fractions. Lastly, we have 7 over 4, and we want to make the denominator 4 to be 40. What will happen to 4 so that you get 40? You realize that 4 times a number is equals to 40. So 40 divided by 4 gives us the new number we want, which is 10. So we shall multiply up here by 10 and define this is the same as 70 over 40. 70 over 40 is an equivalent fraction of the improper fraction 7 over 4. Here is another one. This time round, the numerator is not less than 40, but is larger than 40. What should happen to this fraction to give us the denominator as 40? So you realize that something must have happened for us to reach there. We must have divided 120 by something to get what? To get 40. And that missing digit that we are going to divide with is the one which will give us the value up here. So divide by what we don't know here. What is the number here? Realize that it is 40 divided by, it's 120 divided by 40, which will give us 3, if you are very keen. Therefore, 120 divided by 3 is 40. Therefore, 36 divided by 3 should give us the numerator, which is going to be 12. So 12 over 40 is equivalent to 36 over 120. Write the following fractions in simplest form. Write the following fractions in simplest form. And the fractions are 8 over 20, and another one is 25 over 15. As seen earlier, for us to write a fraction in its simplest form, we need to be able to identify the highest common factor. Having identified the highest common factor, then we shall go ahead and simply divide by that factor. We know the method of identifying the highest common factor, which we can also do mentally. If we were to do it slowly, step by step, we would write down all the factors of 8, which is 1, 2, 4, and 8 itself. And the factors of 20 is 1, 2, 4, 5, 10, and 20. So when they talk of the highest common factor, we are looking at the highest factor which is seen up here and can also be shared with the other one, and we find this one is 4. Therefore, to simplify this, we shall be required to divide by the highest common factor, which is 4 in this case. So take 8 over 20. Divide by the highest common factor, which was 4, and you'll find that 8 by 4, we are going to simplify. We are simplifying, so by 4 is 2, by 4 down here, you'll find that you get 5. So it becomes 2 over 5. This one is the simplest fraction form of 8 over 20. (25) over 15, if we choose to simplify, we should be able to identify the simplest, in the simplest way, the highest common factor between 5 and 15. And this one is telling us the highest common factor is what? Is 5. So by 5 up here, you get 5, and by 5 here, you get 3. So the answer is 5 over 3. So 5 over 3 is our simplest form of the fraction formed when we simplify 25 over 15. I'll also remind you that besides looking at ordinary fractions, there is what we call algebraic fractions. When we talk about algebraic fractions, these are those fractions which are formed by either one of the part, either the numerator or the denominator has got a pronumeral. If that is the case, then we shall treat that as algebraic fraction. And the same way we handle equivalent fraction is the same way we shall handle equivalent algebraic fractions. So let us look at equivalent algebraic fractions. We are asked to fill in the missing number here or expression there. The term that misses here will only be found when you find that these two can be handled. So, given that this left-hand side and right-hand side are equivalent fractions, what is missing? So you'll take, for us to obtain this, it means we multiply it by a certain number. So take 4a divided by 2a to get what is missing. 4a over 2a, a will cancel out, by 2, 1, by 2, 2. So 4a divided by 2a is 2, which means we multiplied it up here by 2, multiply down also by what? By 2. This one, as it gives us 4a, the denominator gives us what? 6b. The denominator gives us 6b. So we can say 2a over 3b is equivalent to 4a over 6b. We have to find the value of the numerator here. But the denominator has been given. That p is our denominator, and the equivalent denominator for the second fraction is 3p. what happened to P to be 3P? What happened to P to form 3P? You'll find that it will be 3P divided by P, which is 3. So this one has been multiplied by 3. P times 3 is 3P. And 4DE multiplied by 3, it should give us a number, a term like 12DE. So what is missing in the box is 12DE. 12DE. Simplify the following algebraic fractions. Simplify the following algebraic fractions. Now, 15b over 20. We have 15b up, we have 20 down. We cannot say there is no common factor because we don't have a pronumeral at the denominator, but look at the numbers. The numerals, do they have anything in common? Yes, 15 and 20 has got a highest common factor of what? Of 5. So we shall simplify here by 5. We get, it is 3b, and the denominator by 5, you will get it is 4. So the fraction, the algebraic fraction 15b over 20 is the same as 3b over 4. We have the power of x this time being introduced, and we have x squared or x power 2. What happens in such situation? As we saw earlier on, we can break this, the numerator, separately so that we write it as a product of its prime factors. This one will be 3 times 5 times x, and the denominator will be 5 times x times x. Why? Because x squared is the same as x times x. Then we start simplifying. The common factor here is 5 and 5. We remain with 1 there. And then x simplifies as one of the x's. Then we shall remain with 3 times 1 times 1. It will give us 3. And the denominator is 1 times x, which is x. So the simplified form of 15x over 5x squared is 3 over x. Is 3 over x. Computation with fractions. Now, when we talk about computation with fractions, we are only referring to a situation where we should be able to add, to subtract, and do other operations related to the fractions. We can add them together, we can multiply them together, we can divide them, we can subtract. That is what we mean by computation. First, how do we go about when we are adding and subtracting fractions? Adding and subtracting fraction. To add and subtract fraction, what are we supposed to know? First, we say that if you are adding fractions with different numerators but the same denominators, then very simple. We maintain the denominator and we do add the numerators. For example, 3 over 8 plus 1 over 8. What is the numerator here? The numerator we have 3 and another numerator we have 1. But the denominator is in both cases for 8, 8. So this one will give us the denominator remains 8, and then the numerator it will be 3 plus what? Plus 1, which gives us 4 over 8. In fractions, we give our answer in the most simplest form. We simplify to the simplest. So by 4 is 1, by 4 is 2. Therefore, 3 over 8 plus 1 over 8 is equals to a half, and a half is equivalent to 4 over 8. So we are saying when adding fractions with the same denominators, we maintain the denominator and we just add the numerators. 2, when subtracting fractions with the same denominators, we actually maintain the denominator and do the operation above by subtracting the numerators. We have 11 over 14 minus 3 over 14. What is the denominator for both two fractions? You notice the denominator is 14. If the denominator is 14, then maintaining 14 as its denominator, we shall maintain 11 minus 3 as the numerator because they were sharing, they have the common denominator. So this one you just subtract the way you do it in integers, 11 minus 3, which gives us 8 over 14. 8 over 14 is not in its simplest form, so we go by 2 is 4, by 2 is 7. We are trying to say that when we simplify this, what you get is 4 over 7. So this is the answer to this question. So what you are trying to say here, when subtracting fractions with the same denominator, we simply do or deal with the numerator by subtracting them and we simplify. How about when the denominators are different? Should we be able to add them? If we are able to add them, how are we supposed to handle them? Since the condition is that the denominators must be the same before you add or subtract. While adding and subtracting, while adding and subtracting fractions, the condition is that you must make the denominator the same. One over 2 plus 2 over 5. Denominators here are different. So the very first thing we need to do here is to find what we call the lowest common denominator. And the lowest common denominator sometimes is found by taking the product of the denominators or finding the multiples that they share of the lowest of the denominators for each case, which you call lowest common denominator or lowest common multiple, LCM. So for this case, it can be done offhand. This is the LCM of 5 and 2 is 10. We are looking for the least multiple that can divide both 5 and what? And 2. And find that the least is 10. We know that even 20 can divide. But is 20 the least? No. Is 40 the least? No. Is 100 the least? No. We look for the least or the lowest common multiple. And that's why we have what we have here. So 10 divided by 2 is 5. 5 multiplied by 1 is 5. Plus 10 divided by 5 is 2. 2 times 2 is what? Is 4. So this one becomes 9 over 10. 9. You'll get 9 over 10. So we have been able to add because we made sure that the denominator is the same. Now, the fact that we are able to add with different denominators, same applies also when you are subtracting. And when subtracting fractions with different denominators, we must find the LCM, the lowest common multiple. Two over 3 minus 1 over 2. Denominators are not the same, so we cannot work with it. We look for the lowest common multiple, and in this case, for these two, it is 6. 6 divided by 3 is 2. 2 times 2 is 4. 6 divided by 2 here is 3. 3 times 1 is 3. So this one becomes 1 over 6. 1 over 6 is our solution and the simplified fraction for this particular part. Now, what happens when you are multiplying? What happens when you are dividing? So let us look at multiplying of fractions. This is a multiplication. When multiplying fractions, you are allowed to just multiply. Just go ahead and multiply without caring. Multiply the numerator and the denominator like that. So multiply the numerators together. This is the same as 1 times 2 over 2 times 3. This one gives us 2 over 6. You simplify. By 2 here is 1. By 2 here is what? 3. There you are. So it doesn't matter whether the denominators are the same or they are not the same. We go ahead, we multiply them, we simplify them, we are done. See, if at all you did want to go it all the way until here, you could simplify from here. The common factors that can be seen, simplify them out, and you remain with 1 over 3. So the two ways still arrive on the same answer. And supposing we are dividing, what should happen here? We want to divide fractions. What should happen? Three over 4 divided by 1 over 4. This is a division. We can't handle it the way we were doing it in multiplication, that the numerator alone and the denominator alone. No. When you are dividing fraction, it is the same as multiplying the first part by the reciprocal. This is the same as multiplying by the reciprocal of the second fraction part. For example, if you have A over B, the reciprocal of A over B is simply to interchange. The denominator becomes the numerator, and the numerator becomes the denominator. So if that is the case, then the reciprocal of A over B is B over A. We have swapped the numerator and the denominator, so what we have is the opposite, that is B over A. So this B over A is the reciprocal of A over B. So when we are dividing by a fraction, we multiply by its reciprocal. So for this case, 3 over 4 divided by 1 over 4, we shall be required to multiply by the reciprocal, so it will become 3 over 4 multiplied by 4 over 1. Simplify where possible by 4, 1 by 4, 1. This is 3 over 1, which is the same as 3 on its own. So this is how we divide fraction. And this other side, if you want to get the reciprocal of a fraction, you simply swap the denominator with the numerator. That is going to be our reciprocal. It is always advisable that you check your answer to be in the simplest form. You check your answer and simplify it to the simplest form. And when we want to divide, take note that we need to multiply by the reciprocal. A situation where you are dividing by a whole number which does not look like a fraction, then you introduce the denominator as 1 so that we can be able to get the reciprocal. I'll illustrate that one here. One over 2 divided by 3. So I've said you introduce a 1 like that, so it is 1 over 2 divided by 3 over 1. And then you multiply by the reciprocal, which is 1 over 2, multiplied by the reciprocal of 3 over 1 is 1 over 3. So 1 times 1 is 1, 2 times 3 is 6. So this one becomes 6. You have been able to swap the numerator and the denominator so that you can multiply by the fraction that we have. Evaluate 3 over 5 plus 4 over 5. Evaluate 3 over 5 plus 4 over 5. The denominators are the same, so this case is simple. We take 3 over 5 plus 4 over 5. What is the denominator? The denominator is 5. Good. And then, what are the numerators? We add them together. It is 3 plus what? Plus 4. 3 plus 4 is equals to 7. And then the denominator was 5. So we can simply say that when you add those two fractions, the answer becomes 7 over 5. Secondly, 5 over 3 minus 3 over 4. Are the denominators the same here? Definitely not. So find the LCM. The LCM, that is the LCM of 3 and 4. The LCM of 3 and 4 is what? It's like the product of the two, which is 12. So the LCM is 12. 12 divided by 3 is 4. Then 12 divided by 3 is 4. 4 multiplied by 5 gives us what? 20. I'll repeat. If the LCM is 12, divide by the denominator of the first fraction multiplied by the numerator. So 12 divided by 3 is 4. 4 times 5 is 20. And then 12 divided by 4 is 3. And 3 times 3 is what? 9. When you subtract that, you find 20 minus 9 is 11 over 12. That is what you get, 11 over 12. We did this because the denominators were not having the same numbers. How about when you are given a simple fractions, and then we have also been given mixed fractions and maybe improper fractions? Are we able to add and subtract mixed numerals? So let us look at this question. Evaluate. Evaluate 3 and 5 over 8 plus 2 and 3 over 4. This is a situation where we have mixed numerals. Earlier on, I asked you to refer to your notes and see what do we mean when we talk about mixed numeral. A mixed numeral is simply the term made up of a whole number part and a proper fraction part. For example, the two that we have on the board are all mixed numerals. Now, there are several approaches we can give here. One of the approaches, add the whole numbers together and then add the fractions together, and then if the fractions is greater, is improper, then we simplify and bring the whole numbers. That is just a long story. In mathematics, you calculate. You show you are working. So let us show what we know. Don't imagine what you think you know. So you will be required to handle this and change it into improper fraction. Do you know how to change a mixed numeral into improper fraction? This is 8 times 3, 24. 24 plus 5 is 29. So this 29 over 8. So if you don't want to write it as a mixed numeral, convert and write 29 over 8. This is the improper fraction of this mixed numeral. And the second part, 4 times 2 is 8, and 8 add 3 gives us 11 over 4. What is the lowest common denominator? The LCD. 8 and 4, they share a multiple of what? 8 itself. So the LCM is 8. 8 divided by 8 is 1. 1 times 29 is 20 what? 9 plus. 8 divided by 4 is 2. 2 times 11 is 22. When you add the two together, 9 plus 2. 9 plus 2 is what? 11. Carry 1. 1 plus 2 is 3. 3 plus 2 is 5. So this one you're getting 51 over 8. 51 over 8. What happens to 51 over 8? This 51 over 8 can be simplified and written as a mixed numeral, or it can just be left there as an improper fraction and you say, that's my answer. It's already the answer. If you chose to simplify, then you would divide here, and you find that you are looking for maybe a number. 51 divided by 8 is 6, because of 48, remainder 3. So it is 6 and 3 over 8. 6 and 3 over 8. 8 times 6 is 48 plus 3 is 51. So we've not changed anything. What we've written is just the same. What if we were subtracting mixed numeral? Evaluate 2.5 minus 1 and 5 over 6. As I've just said, convert everything into improper. Make sure the denominator is the same and carry out your operations. As simple as that. 2 times 2 is 4. 4 plus 1 is 5. So we have 5 over 2 minus 6 times 1 is 6. 6 plus 5 is 11 over 6. This one gives us what? The denominator. What is the lowest common denominator or lowest common multiple of both 2 and 6? You'll find that they share the same lowest common multiple of what? Of 6. 6 divided by 2 is 3. 3 times 5 is 15. Minus 6 divided by 6 is 1. Times 11 is 11. So 15 minus 11 is 4 over 6. You can simplify by 2 is 2. And by 2 is what? 3. So we can simply agree and say the answer to this is simply 2 over 3. Now, we've worked through this, but there are also other methods which I want you to look at. We looked at them in our previous classes when we were doing computation of fractions, addition and subtraction of fraction. I want you to look at what are the other methods that we can use to deal or to evaluate mixed numeral if we don't want to convert everything into improper fraction and then we do what and then we add or we subtract. It is very, very important that we know how to work out the least common multiple, which I'm calling the LCM, or the least common denominator. That is what we normally do when we are dealing with those fractions which don't have the same denominator. So that is it for now. When we come back, we shall now be looking at further fractional computation, dealing with both division and multiplication.